All right, so 3.5, solving polynomial equations, part 2. We've got number 1 here, you got to find all possible real zeros, which is different than number 2 where it says find all real zeros. So the possibilities have to be the factors of your constant, in our case 12. So let's see, the factors of 12, I could have a positive or negative. 1 times 12 is 12. I could have 2 times 6, that would give me a 12. 3 times 4 is 12. Okay, so thinking these are my factors of 12. And then that's got to be over the factors of the leading coefficient, 3. So positive and negative, it's a prime number, so just 1 and 3 going evenly. All right, so let's look at all the possibilities. Let's do 1 divided by 1 and 1 divided by 3. 1 divided by 1 is 1. 1 divided by 3, so 1/3. Again, I still have a positive or negative of each. All right, so those are each possibilities. And now let's do this next number 12. 12 over 1 and 12 over 3. 12 divided by 1 is 12. 12 divided by 3 is 4. Okay, so a positive or negative 12 or 4, also options. Let's do the 2 over each of these. And my 2 over 3. So 2 divided by 1 is 2. And 2 over 3, so 2/3. Okay. And next up, let's do the 6 divided by each of these. 6 divided by 1 is 6. And 6 divided by 3 is 2, which I actually already had 2 in my list. Once it's in my list, I don't need to put it in there again. All right, so that 2 is there. I have got 3 over 1 and 3 over 3. 3 over 1 is 3, and 3 over 3 is a 1, which again is already in my list. So I actually don't need to put the 1 in there again. And then move on to our last number, 4. So 4 over 1 and 4 over 3. 4 divided by 1 is 4, already in my list. 4 divided by 3, the fraction 4/3, that is not in there yet. Okay, so these are a positive or negative, each of these numbers, these are all the possibilities. Now, in number 2 here, I'm going to use my possibilities to see which ones work and which ones don't. So bust out my calculator and start plugging in some of my options. So let's see what our options are. The factors of 16. I could have a positive or negative of each. So 1 times 16 is 16. Let's see, 2 times 8, 4 times 4. And I think that's, again, as good as it's going to get. The factors of the leading coefficient, 2 is a prime number. So I got a 1 times 2 is 2, and that's pretty much it. All right, so let's start checking some of our possibilities. All right, so my first would be 1 divided by 1 and 1 divided by 2. 1 divided by 1 is 1, 1 divided by 2 is a half. Okay, so these are all possibilities. I can do 16 over 1 and 16 over 2. So 16 over 1 is 1, or sorry, 16 divided by 1 is 16, 16 divided by 2 is 8. Okay. 2 divided by each of them, 2 divided by 1 is 2, and 2 divided by 2 is a 1, which is already in my list, so I don't need to put it there again. It's 8 divided by 1 is 8, already in my list. 8 divided by 2 is 4. Okay, I'll add that to my list. And the last number, 4. 4 divided by 1 is 4, already in my list. 4 divided by 2 is 2, already in my list. So actually I am done with those. These are all my possibilities, positive and negative of each. So let's test and see which worked. So in my calculator, I've got 2 times x cubed. I'm treating the 1 as my x, testing to see if this works. If it does work, this will turn out to equal 0. A remainder of 0 means that it goes in evenly. (16 times x), again, my x is a 1 still, and then plus 16, okay. Okay, so my 1 was close to 0, it wasn't exactly 0 though. So 1 is out. Let's try, I don't know, I'm gonna try the nice, pretty whole numbers first. I'll try like a 2. Okay, I'm plugging in for all of the x's. All right, negative 20, so ooh, definitely not that one. The 1 didn't work, the 2 didn't work. Let's see, we got a 4, 8, 16. Let's check these out. Oh, the 4 gave me a remainder of 0. Okay, so 4 works. Let's go ahead and do some division to factor it out. I'm going to put that 4 in the box here. Again, I got the 4, positive 4. And we're going to do some synthetic division. I got a 2x cubed, negative 5x squared, negative 16x, and a positive 16. I hit every exponent on the way down, and I should end up with a remainder of 0. Okay, so I bring down the first number, multiply by what's in the box. So 2 times 4 is 8, and I add straight down. That's where I get my 3. Multiply by what's in the box. Okay, 3 times 4 is 12, add straight down. Multiply what's in the box, so negative 16, add straight down. Nice, 16 and negative 16 add up to 0, which is what we were going for, which means this set of numbers down here gives us our remaining polynomial. We already factored out the x minus 4 factor. That means I've got a 2x squared plus 3x minus 4 remaining. All right, so I actually have one of my zeros already. Positive 4 is one of my zeros. I need to see if I can either factor this, or I could just use the quadratic formula on this leftover part here. So I think I'll probably just go with the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. And again, I already have that x equals a positive 4. I could have up to, since it's degree 3, I could have up to 3 solutions, zeros that it's asking for. All right, so I'm going to do the part under the parentheses, or sorry, under the square root first. All right, 41, good thing that I did the quadratic formula because it's not a perfect square. It's not easy to do the square root of 41. Now, a lot of times I would pay attention to what the instructions tell you. If they tell you to round, great, go ahead and put that whole thing in your calculator. If they want an exact answer, then actually this would be as good as it's going to get. I can separate it into 2 different x values, but they still would be kind of messy here. Negative 3 plus the root 41 over 4. And x equals the negative 3 minus, there's my plus or minus on the root 41 all over 4. Okay, so solutions. I've got 1, 2, 3 solutions. Okay, find all real zeros. Those are my 3 real zeros. And then number 3 has you basically going backwards. Write a polynomial function f of least degree that has a leading coefficient of 1 and zeros of negative 3, 4, and negative 1. So instead of factoring the polynomial, I am going to take the zeros, put them into factors, okay, and then I will distribute that and come up with a polynomial like they started with. They started with the polynomial on number 2 here. So let's do some distributing. Maybe I'll multiply these first 2 together first. So I'll distribute my x. I get x squared minus 4x. And then I will distribute the 3. I get a 3x minus 12. All right. So that's just those first 2. I can combine some like terms here. But I haven't messed with the x plus 1 quite yet. So now let's go ahead and finish this off, distribute to the x plus 1. So x squared times x gives me my x cubed, and x squared times 1, okay. Next, distribute the negative x. All right, and now I'm going to distribute the negative 12. All right, so I will combine some like terms again. I cut a couple x squareds, a couple plain x's. All right. Because I have a positive and negative x squared, they basically add up to 0, or some people say cancel out, same thing. My plain x's, negative x, it's like a negative 1x minus 12x. Negative 1 minus 12 is negative 13, so I've got negative 13x, and I still have the x cubed at the beginning and the negative 12 at the end. Okay, so there is the polynomial function. It's the least degree. They gave me 3 zeros, so I should have had a degree 3 polynomial, which I have. And then a leading coefficient of 1, meaning leading as in up front here, I have a 1x to the third. All right, so there is the polynomial that we're going for. And on number 4, write a polynomial function f of, again, least degree that has rational coefficients, a leading coefficient of 1, and zeros are 3 and 2 plus root 5. Now, in this case, because you have to have rational coefficients, this root 5 is not rational. It's telling me that I need to have its conjugate as another 0. So currently I have a 0 of 3, a 2 plus root 5, and I have to add another 0 of 2 minus root 5. Okay, so let's do like we did up here. But on the previous one, I had nice pretty whole numbers, but I gotta now take the 3 they gave me, the 2 plus root 5, and its conjugate, the 2 minus root 5. Okay, into their factors. I've got an x minus 3 and x minus 2 plus root 5. Notice I'm using the parentheses around that. And x minus the 2 minus root 5. Okay, my point is make sure you distribute the negative to both the 2 and the root 5. So this is going to be an x minus 2 minus root 5 and an x minus 2 plus root 5. All right, the x minus 3 has not changed. So I think I'm going to start with these guys because they are conjugates. If I do this right, I should have no more square roots. So I'm going to distribute my x. I get x squared, negative 2x, and a positive root 5 times the x. All right, and then I'll distribute my negative 2. Okay, so negative 2x plus 4 and minus 2 root 5. And then the negative root 5, I will distribute to get a negative root 5 times x, a positive 2 root 5, and a negative square root of 25. My 5 times 5 is 25. Okay, so that is those really messy ones. I have not messed with the x minus 3. But if I did this right, all of the square roots in the parentheses here should kind of cancel each other out. I got a positive root 5 times x and a negative root 5 times x. Positive, negative, those add up to 0. All right. Negative 2 root 5, positive 2 root 5. Again, same thing, positive and negative. So they're gone. This other square root, it doesn't really cancel anything out, but I do know the square root of 25 is a nice pretty whole number. That's a 5. Keep in mind you are subtracting that, so it's a minus 5 there. All right, so that means if I combine some like terms here, I get x squared. Let's see, like terms, my negative 2x, so a negative 4x with those guys. Let's see, I also have a positive 4 and a negative 5. So 4 minus 5 gives me a negative 1. Okay, and I still haven't touched this x minus 3 yet, but no more square roots. This is looking good. I'm going to distribute my x through here. Okay, so I get x cubed minus 4x squared minus a 1x, or just plain x, and then I'll distribute my negative 3. So I get a negative 3x squared, positive 12x, and positive 3. When I combine my like terms, it looks like I've got x cubed. I have a couple of x squareds here, so negative 4, negative 3, combined for a negative 7, negative 7x squared. Let's see, a negative x and a positive 12x, so it's like negative 1 plus 12 is a positive 11. Positive 11x, and then my constant term plus 3. All right, so here's the polynomial with the zeros that they gave us. And then the last problem here is to solve the equation f of x equals g of x for these specific f of x and g of x functions they gave us. So they said f of x, here's my f of x, equals the g of x, so here's my g of x, all right, and so I'm going to solve this by probably getting everything on one side of the equation and all equal to 0. So I'll subtract my x squared on both sides, subtract a 7x on both sides, and add 6 on both sides, all right? Which means I just have 0 on the right side here. The left side has a 1x squared, a positive 2x, and a plus 1, which I would either factor or use the quadratic formula. I think I can factor this one. The things that multiply to 1 and add up to 2, it's got to be a 1 and another 1. 1 times 1 is 1, and 1 plus 1 gives me the 2. I also need an x at the beginning of each. So when I set these factors equal to 0, they're actually both the same factor. So I really just need to do one of them. It looks like x equals negative 1. So we have solved the equation. X equals negative 1, and you can always, as usual, plug it back in and see if it actually works. All right, there we go.